let us find out potential due to a point charge. Here we are given a point charge, that is Q, at the origin. Okay, and then we have to find the potential due to this point charge at a point P. And the position vector of P is given by R. This is vector R, the position vector. And to do that, we actually have to establish certain things, that there is another charge which is called a unit positive test charge. So unit positive test charge will be of +1 coulomb. So we have to establish that first this charge is at the infinity, that is very far. And then a work done has to be done, a force has to be applied on this charge to bring this charge from that infinity to this point P. Then we also have to establish that the charge Q, the point charge Q at the origin, is a positive charge. So capital Q is greater than 0. Okay, so it will exert a force on the test charge, which is at +1 coulomb at infinity. Okay, the force will be exerted. So this force is actually electrostatic force, and to bring this charge, the test charge, from infinity to that point P, we have to apply the same amount of force in opposite direction. All right, but to actually derive all these things, we need to do something else. We need to find an intermediate point P dash. So this is the intermediate point P dash between infinity and the point P. Okay, and the distance of this P dash from the origin is R dash. And the best way to bring that charge from infinity to the point P dash or P, whichever, is just the radial direction from infinity to the point P. So this direction we are talking about is straight. Though path is not at all important, so because work done is independent of the path, but a convenient way is to just go through the radial direction. Now, since we have chosen intermediate point P dash, and we have established that the P dash is R dash distance away from the origin, now electrostatic force at any unit positive charge at this point P dash is F is equal to capital Q. So this is capital Q, or better I write F is equal to, just a moment, 1/4 pi epsilon naught, and then one charge, and then the other charge is 1 coulomb, so we'll just write 1, and divided by the distance between these two charges, that is R dash square. And then since this is a vector quantity, force is a vector quantity, so we have to use a vector element, and that is R dash cap. This is the unit vector, and the force is towards the infinity from the origin. So from origin to infinity. So this is the direction of the force. Now to derive the expression for potential at a point, we need to go step by step. So the second step is finding a small distance, that is delta R dash, from P dash and towards the point P. So a very small distance is covered by the test charge with the help of some external force. So we actually we don't know what kind of external force is there. So but we know one thing about the external force, that is the external force is of equal magnitude that of the electrostatic force, because these we have to use the same amount of force what the electrostatic force is there that gives the push, but in opposite direction. Okay, that we have covered in the previous video if you go through those videos. Now to do that, then when this external force is of the same value, F external is of the same value that of the electrostatic force. So same kind of external force we have, same value of external force we have to apply. Okay, but we have to keep in mind that this is just the opposite direction of the electrostatic force. So we will just use a negative sign. Now the work done, okay, by the external force to bring the charge from point P dash to this point. So what is the displacement or distance covered? That is delta R dash. Okay, so the work done for this distance is actually force multiplied by the quantity delta R dash. What you can see here, so force is Q upon 4 pi epsilon naught R dash square, but it is a negative force here because the force is in opposite direction. That's why this negative sign comes, and then we multiply it by delta R dash. Okay, so and simply we can say actually work done is force multiplied by the displacement. Okay, this formula we have used here. Though it looks like that this work done has a negative sign, but actually work done is positive. Why? Because delta R that we are multiplying here is also a negative quantity. So negative will become positive when we multiply two negatives. So delta R dash is actually a negative quantity. Why? Because it is going in opposite direction to the direction of the radial vectors here, the position vectors we talked about. Okay, now this is the work done from to bring the charge from P dash to a small distance delta R. All right, but what is the total work done? So total work done is actually integrating this quantity delta W, which is minus Q by 4 pi epsilon naught R dash square, and then the differential element dr, okay, which delta R we talked about. Now we are integrating it. So these values are the constant values. This will just come on the left hand side, and here only R is the one which is a variable. So total work done to bring the charge from infinity to the point P, that is R, in that our limits are infinity to R. Okay, so it will become Q upon 4 pi epsilon naught, and then 1 by infinity minus 1 by R. Okay, and a negative sign is already there. So now 1 by infinity is simply 0, so 4 pi epsilon naught, and then 0, and then this minus and minus will become plus. So first of all we'll just write 1 by R, and then further it will be plus. So this quantity is actually plus Q minus minus plus Q by 4 pi epsilon naught and multiplied by R here. Okay, so this is the work done. But what you see, the potential is also the same. But keep in mind the units of work done is different and that of the potential is different. But potential at R, what is that? It is actually work done by the test charge. And what is the test charge here? Just 1 coulomb. So divided by 1. Okay. So this will be exactly equal to what we got from the work done, that is Q upon 4 pi epsilon naught R. And this what you see it here. So potential at a point P due to a point charge is Q upon the point charge upon 4 pi epsilon naught R. R is the distance from origin to the point where we want to find the potential. I hope you understood the concept. Just keep in mind that your electric field varies by, it is inversely proportional to 1 by r square. Force is also inversely proportional to 1 by r square for a point charge. But our potential is inversely proportional to 1 by r, just 1 by r. Thank you.